the study guide for section 6.7. It's on using the distance formula. The first half of this page is dedicated to showing you how to find the distance between these two ordered pairs. So if you didn't know how to find that distance or that measure, you would use this formula and you would plug these numbers in. And you could work it out step by step or just type it in from here and it'll give you this answer. We need to pay extra special attention to the study guide because it shows you what to do. Don't just ignore it. We're going to find the distance between each pair of points, just like they did up there. Round to the nearest tenth if necessary. We're going to go to the nearest hundredth, so that's 2 decimal places. Here's an ordered pair C. It lives at 1, 0. Here's the ordered pair D. It lives at 4, 2. I'm going to use a straight edge and I'm going to connect those two ordered pairs C and D. How long is that distance? Well, since it's graphed on a coordinate plane like this, you could see, if I wanted to, couldn't I make a little right triangle underneath here? And I could count this distance and this distance, and I could find that length. Remember the Pythagorean theorem. This goes from 1, 2, 3, 4. So it goes from 1 to 4. This has a length of 3. This vertical piece has a length of 2. So you have a right triangle where the legs are 2 and 3. How long is the hypotenuse? Okay, so that's the connection between this distance formula and the stuff we did before with the Pythagorean theorem. Okay, so if I was just to type that in there exactly how I just said it, square root of 2 squared plus 3 squared gives you that length, 3.61, I'm going to call it. Where did we go? Oh, that's point C. C to D equals 3.61, I'll call it. Now, I'm going to take a second and show you that this is exactly the same thing as the distance formula. So I'm using the distance formula now to show you that I'm going to subtract my x's, 4 minus 1 squared, and I'm going to add that to my y values now. My y values would be 2 and 0. 2 minus 0. See, that's the same exact number. So this second way I use the distance formula. This first way I use the Pythagorean theorem. I just made a little right triangle underneath my diagonal segment. Same answer. Let's skip down to the next section. We're going to graph each pair of ordered pairs, then find the distance between the points. Round to the nearest tenth, we'll do hundredth if necessary. M lives at 3, 1. So there's point M. N lives at 1, negative 4. That's point N. I want to find the distance between those ordered pairs. If I want my answer, you can use the distance formula. Or, my other pens here, I could make a right triangle. Make sure you can see what I'm doing here. And I could use the Pythagorean theorem. That horizontal distance is 2. This vertical distance is 5. So you have a right triangle where the legs are 2 and 5. So how do you find the hypotenuse? Well, you take the square root of 2 squared plus 5 squared. Whoop, 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 whoop. What the heck just happened? And that gives you that answer, 5.39. So that's our answer here. From M to N is 5.39. That was using the Pythagorean theorem, which we did last section. This section, we can use the distance formula. So what I'm going to do is I'm going to use these ordered pairs, and I'm going to type in the distance formula. And you better get the same answer, otherwise math doesn't make a lot of sense. 3 minus 1 squared plus, we'll do negative 4. Now notice, I didn't do 3 minus 1, I did 3 minus this one. So you need to do 1 minus negative 4. squared better give you the same answer, and it does. So distance formula or Pythagorean theorem. The distance formula comes from the Pythagorean theorem.